Why was the square root of a shock to the Pythagoreans? Imagine discovering that some numbers are not like the others, that they cannot be written as simple fractions. That's exactly what happened to the Pythagoreans when they found out about the square root of 2. They believed all numbers could be expressed as ratios of whole numbers, like 1/2 or 3/4. Their whole worldview was based on the idea that the universe was built on these ratios and whole numbers. Now think about a square with sides of 1 unit each. The diagonal of this square can be found using the Pythagorean theorem. You square the length of each side, add them together, and then take the square root to find the length of the diagonal. So, the diagonal squared equals 2. The length of the diagonal is the square root of 2. The problem was, the Pythagoreans thought this length should be a simple fraction, like 3/2 or 7/5. They tried to find such a fraction, but no matter how hard they looked, they couldn't find one. The decimal form of the square root of 2 goes on forever without repeating, which means it's an irrational number. It cannot be written as a ratio of whole numbers. This discovery was a big shock because it challenged their belief that all numbers could be expressed as ratios. It showed that there are numbers that don't fit into their neat system. The Pythagoreans believed in harmony and order in numbers, but irrational numbers like the square root of 2 broke that idea apart. Legend has it that the person who discovered this, Hippasus, was either ostracized or even harmed by his peers because they didn't want to accept this new idea. This event marked a turning point in math history. It made mathematicians realize that the world of numbers was bigger and more complicated than they thought. From an algebra perspective, this discovery is important because it introduces the concept of radicals, which are expressions involving roots. It shows that not all roots produce rational numbers. This is why algebra includes irrational numbers as a fundamental part of the number system. Understanding that the square root of 2 is irrational helps us see why some equations have solutions that can't be written as simple fractions. In real life, this idea is useful in geometry, measurement, and algebra. For example, when measuring the diagonal of a square or certain polygons, you can't always get an exact fraction. That's why irrational numbers are essential for precise calculations. So, the shock to the Pythagoreans came from the realization that some numbers are not rational, which led to the concept of irrational numbers. This discovery expanded the way we understand numbers and laid the foundation for the study of radicals and the broader number system used in mathematics today.